Good day everyone. Today I will discuss the fuel injectors, fuel pressure regulator, fuel pump, fuel tank, and fuel lines. Fuel injection is the introduction of fuel in an internal combustion engine, most commonly automotive engines, by the means of an injector. This article focuses on fuel injection in reciprocating piston and one-coil rotary engines. All compression engines and many spark ignition engines use fuel injection of one kind or another. Mass production produced diesel engines for passenger cars became available in the late 1930s and early 1940s, being the first fuel-injected engines for passenger car use. In passenger car petrol engine, fuel injection was introduced in the early 1950s and gradually gained prevalence until it had largely replaced carburetors by the early 1990s. The primary difference between carburation and fuel injection is that fuel injection atomizes the fuel through a small nozzle under high pressure, while a carburetor relies on suction created by intake air accelerated through a venturi tube to draw fuel into the airstream. The term fuel injection is vague and compromises various distinct systems with fundamentally different functions principle. Typically, the only thing in common all fuel injection systems have is a lack of carburation. There are two main function principles of mixture formation systems for internal combustion engines: internal mixture formation and external mixture formation. A fuel injection system that uses external mixture formation is called the manifold injection system. There exist two types of manifold injection systems: multi-point injection or port injection and single-point injection or throttle body injection. Internal mixture formation systems can be separated into direct and indirect injection systems. There exist several different varieties of both direct and indirect injection systems. The most common internal mixture formation fuel injection system is the common rail injection system. A direct injection system, a term electronic fuel injection, refers to any fuel injection system controlled by an engine control unit. Fuel pressure regulator. A fuel pressure regulator helps maintain the fuel pressure in the electronic fuel injection system. If the system needs more fuel pressure, the fuel pressure regulator allows more fuel to go to the engine. This is important because that is how the fuel gets to the injectors, blocking the pass-through to the fuel tank off completely. The fuel pump will try to force too much fuel into the injectors, which will cause them to fail and you will end up needing another auto repair service. Fuel pressure regulators are a vacuum-operated spring-loaded diaphragm enables a vehicle fuel delivery system to maintain a constant pressure. When the vehicle is at idle, the regulator is open, allowing fuel to bypass the delivery system and go back into the tank. When the engine produces more vacuum under load, the pressure regulator diaphragm closes and allows an increase in fuel volume to be provided to the injectors while maintaining a consistent pressure. You will find fuel pressure regulators typically located at the end of the fuel rail on mechanical return systems, or at the fuel tank in mechanical return less fuel delivery systems. Fuel pump. A fuel pump is a component in motor vehicles that transfers liquid from the fuel tank to the carburetor or fuel injector of the internal combustion engine. Carbureted engines often use low-pressure mechanical pumps that are mounted outside the fuel tank, whereas fuel-injected engines often use electric fuel pumps that are mounted inside the fuel tank And some fuel-injected engines have two fuel pumps, one low-pressure, high-volume supply pump in the tank and one high-pressure, low-volume pump on or near the engine. Fuel pressure needs to be within certain certifications for the engine to run correctly. If the fuel pressure is too high, the engine will run rough and rich, but combusting all of the fuel being pumped, making the engine inefficient and a pollutant. If the pressure is too low, the engine may run lean, misfire, or stall. Types of fuel pumps: mechanical, electrical, and high pressure fuel pump. What is mechanical fuel pump? Mechanical fuel pump, these are basically low pressure type of fuel pumps, sometimes also used for high pressure, whose main work is to transfer the fuel from the tank to the fuel bowl of the spark ignition engine. The mechanical fuel pump consists of two kinds of pump: diaphragm type fuel pump and plunger type fuel pump. Diaphragm type fuel pump is basically a positive displacement pump which shocks the fuel by expanding and contracting motion of the diaphragm. The pump body consists of inlet and outlet check valves, which are the one-way valves. As the diaphragm contracts, the pressure inside the pump becomes lower than the atmospheric pressure and the fuel gets sucked through the inlet valve. And as the diaphragm expands, the fuel inside the pump pushes out through the outlet valves. The expansion and contraction motion of the diaphragm is controlled by a lever actuated by an eccentric cam motion. This eccentric cam is connected to the crankshaft of the engine through proper gearing arrangement. And plunger type fuel pump. The plunger type fuel pump is also a positive displacement pump which shocks and delivers the fuel by the help of reciprocating motion of the plunger. The plunger is enclosed inside the cylinder and one side of the plunger is connected with a push rod which further connects the camshaft. The valves are mounted on the end of the cylinder. As the plunger moves backward, the fuel gets sucked into the cylinder, and within the forward motion, the plunger fuel gets delivered out of the cylinder. Although the pressure of the fuel supplied from the mechanical pumps are constant, but it requires proper maintenance because of lots of moving parts. These pumps are become obsolete nowadays because the vehicles are changed their injection system from carburetor to the fuel injection system. The second one is the fuel pump, electric fuel pump. These kinds of pumps are generally used in fuel injection system, which are the essential part of the modern motor vehicles. It creates the high pressure to deliver the fuel out of the pump. This high pressure may cause the fuel to ignite inside the pump itself and may be reason of explosion. The current to operate the fuel pump is supplied by the battery of the vehicle. An ECU or electronic control system is also available there which properly controls the output pressure and volume of the fuel, and in addition, it also meters the incoming fuel from the tank. The ECU helps the vehicle to save fuel and hence gives a better mileage of power. Number 3. High pressure fuel pump. These pumps are generally used for the injection of fuel into the combustion chamber. Specifically in combustion ignition engines, these types of pumps work above 200 pascals. To handle such a high pressure, these pump systems are made complex and sturdy. The general high pressure pump system having flow rails, metering units distributing units, etc. This helps the pump to supply the fuel into the combustion chamber without any wastage or fueling. Fuel tank. A fuel tank in the vehicle is an important component of fuel system in an internal combustion engine. A tank is used to store motor fuel such as petrol, diesel, fuel, and gas. The present-day fuel tanks can be made of different advanced materials or ferroalloys, aluminum alloys, or plastics. And last, the fuel line. A fuel line is a hose used to bring fuel from one point in a vehicle to another or from storage tank to a vehicle. It is a commonly made of reinforced rubber to prevent splitting and kinking. All parts of the fuel systems are connected by fuel and vapor lines and hoses. This permits delivering fuel to the carburetor, returning excess fuel to the tank, and carrying fuel vapor. Fuel lines should be routed to stay as cool as possible. If any part of the fuel line is accessible to overheating, the gasoline passing through it evaporates more quickly compared to a fuel pump can create suction. Lower pressure or partial vacuum in the fuel pump also causes fuel to vaporize. This condition produces a vapor lock due to which the fuel pump delivers only vapor to the carburetor. Also, the vapor goes out to the ball vent without the engine receiving or any gasoline. And that's all. Thank you.